Okay, so for problem 1 set 2, I said that A was true. Here I just started out by expanding this squared sign. I did that, then I multiplied it out. Then I saw that this sine x, cosine x was written twice, so I did 2 sine x cosine x plus cosine squared x. Then I subtracted this 2 sine x cosine x and put it on this side. Then I saw that this sine squared x and this cosine squared x added up to 1. So I said 1 is equal to this. Then I added this back to this side, and I was left with 1 plus 2 sine x cosine x equals 1 plus sine of 2x. And then the double angle identity tells us that 2 sine x cosine x is equal to the sine of 2x. So I was able to just add it like this, and I saw that these two were equal, so I said it was true. Now for this one, I multiplied this by sine of x, I multiplied this by 1 minus cosine of x, and this one by sine of x. Then this is what I wrote down. Then here I pretty much just multiplied this out, expanded it, and added it. Then I added this. Then I combined this negative cosine x with this negative cosine x, and I got negative 2 cosine x. Then I wrote that down here, but the sine squared of x got added with this cosine squared of x over here, and I knew that that equaled 1, so I was left with 1 minus 2 cosine x plus 1, which I wrote down here. Then I wrote just the denominators. And then I said that that was equal to 2 minus 2 cosine x because I combined this one and this one, and I was left with 2. Then I saw that the denominator, this 1 minus cosine x, canceled out with this one, and that this was 2 over 1. So then I was left with 2 over the sine of x, which would be equal to 2 cosecant of x, which is not equal to the 2 secant of x, which is what it had said. So I said it was false. And then over here, I used the quotient identity, I think is what it's called, to say this pretty much. And then I multiplied this thing by the sine of x and this thing by the cosine of x, so they would be the same denominator, and I could add them. Then I multiplied this, and I got sine squared x and cosine squared x. Then since this is equal to 1, I said that this was 1. I don't know if you can see that. I said that that was 1. And anyway, I just multiplied that out. And then I was left with this. Then I just split up the fraction. And since these two could cancel out, I was left with 1 over the cosine of x. And since these two could cancel out, I was left with 1 over the sine of x, which is equal to the secant of x and the cosecant of x, which is what we had said it was originally. So I said it was true.